I suspect you have an even bigger vision for what agency will be in the future. But already today, it sounds like it blends together a lot of different kinds of functionality that different people have provided. Like, MCP provides tool use for agents, and then A2A is a framework from Google that is allowing inter-agent collaboration. It sounds like with agency, you're trying to provide an open source framework that allows all of these things together.
That's right. And I think so. If you think about how we took agency and moved it to the Linux Foundation, the formative members for the agency project in the Linux Foundation are, of course, Cisco, but there's Dell, there's Google, there's Red Hat, and there's Oracle. Those are the formative members. And then there are about 80 other organizations, both small and large, that are contributing, using, uh, and deploying this at scale. So that's roughly where things are with agency. But also, like you said, so we on the protocol side, we do collaborate with A2A as well as MCP, and we are a foundational member of the A2A project that Google brought to the LF. So if you think about A2A, we are a foundational member, and Google is a foundational member of agency because we believe that fragmentation at this stage is a really bad thing. As it is, people are having trouble deploying agents, building agents, getting some traction and outcomes out, especially in the enterprise. And if you confuse everyone with multiple standards, multiple open source projects, we're not doing justice as technologists. So we all came together and made sure that when we say it's open and interoperable, we are truly being interoperable. And so if you think about the agency architecture, we actually show MCP as a protocol going from agents down to tool use and to data sources. And we show A2A as a protocol that sits between agents. Now, we are Cisco, we are a networking company, we've done this a while, and we all know that protocols are protocols and there'll be many, many protocols. And so the way we think about agency is we love all protocols. We love MCP today and A2A today. There might be five others that might prop up. If you think about the internet, you have IP, you have TCP, you have UDP. Even they were not sufficient, so the industry came up with Quick. So there are many, many protocols that come along. I mean, there's HTTPS that sits above all of this. So there'll be many protocols, and I believe that we are at the cusp of redefining that protocol stack that exists, and we can dive in that direction if it makes sense.
Yeah, let's do that a little bit. Because so terms like TCP, IP, for us data science listeners, we might not be familiar with that. HTTP, we have some idea because we see that in the web address. So, you have some idea that it has to do with the way that web pages are sent over the web securely. But TCP IP, I mean, having somebody from Cisco, you can probably explain that better than most people. And critically, you have a PhD in computer science from UC Davis that you got in the 90s. And so you have compared previously, you've compared today's agent ecosystem to the pre TCP IP days of the internet. So I'd love to hear, first of all, TCP IP, I know it's really important for the way that the internet works, but I wouldn't be able to explain it. So I'd love it if you can explain it and then explain how the moment that we're in today is analogous for agents.
So think about the early 90s. I mean, this was, again, when I was a bright eyed undergraduate. The internet was just coming out. This was 1995. And we had dial up. And I don't know if listeners here would remember it or even have experienced it.
I'm sure we will, because I did.
And so if you remember that dial tone where you would connect the computer to the internet through AOL, and AOL would come on a CD, you would pop it in, or maybe even a floppy, and you would pop it in, and it would dial into a phone line somewhere, and you would get 56, and I'm going to mess this up, you'll get 56 kilobaud or something like that. I don't even remember what it used to be. Really slow, let's put it that way. Really, really slow. internet connectivity from a single provider, AOL. And so you had these islands of connectivity, and these islands never talked to each other. You had DECnet and Apple Talk and IBM SNA and a whole bunch of these other protocols and islands. And these networks actually did not talk to each other. It might seem surprising, but I'm on a Mac right now, and I should be able to just talk to Macs if Apple Talk was the de facto king. And if you're on a Windows machine, tough luck. If you're on a phone, tough luck. And so TCP/IP came in because Windsurf, in one of these meetings, stood up and said, "Enough is enough." You have BSD TCP/IP stack that was embedded in the BSD operating system from Berkeley, which was open sourced. And he came in and said, "We are all going to standardize behind the TCP/IP stack." And one of those books actually sits on my bookshelf over there. But that was a seminal moment in networking and Cisco was a big supporter of that. And what that did was it allowed packets from one box to flow to another box without it being siloed through a business need or a business requirement. So you truly opened it up, you truly made the network interoperable. And that's how the internet was formed, because everybody signed up behind TCP/IP. We are at a similar juncture for agentic communication where, yes, some of us are talking to each other, but some of us aren't. And like I said, we did not stop at TCP/IP because it was invented in the 90s, I think late 80s, early 90s. The world has evolved. And so the requirements of TCP/IP have changed over time. So the reason QUIC came about is we needed the same guarantees of communication that TCP provides. I need to ensure that you and I, when I say a word, does reach you and vice versa. So I need that guarantee. But then TCP is pretty heavy. And I need that word to be transmitted to you, especially for communications, very swiftly with low latency. Because the one thing people hate is delays when you see audio or video. And so something like QUIC came about to marry the best of both worlds between TCP and UDP. So it gave the guarantees of delivery, but it also provided low latency interactive communication. Similarly, what we are seeing on the agent side is, yes, we have MCP, yes, we have A2A, but there are many, many needs for agent to agent communication. And over time, we will see many protocols pop up. And as we create those protocols for a variety of needs, we need to make sure that there is a scaffold that exists around them, the scaffolding of discovery of agents. This is like the DNS. You said data scientists only know the URL. So how does a URL translate to an IP address, which you don't really care about, but it does translate to an IP address? How does that happen? That happens through DNS. And so what is the DNS system for agents? How do we do agent discovery and capability discovery? That's a scaffold around TCP/IP. That's a scaffold around A2A and MCP. So the discovery, the identity, of course, the messaging layer that we just talked about, and the evaluation pieces that I mentioned earlier, this is the scaffold that needs to exist, regardless of the number of protocols that we all as an industry come up with.